Can you imagine a world where robots not only work, but also learn, adapt, and coexist with us? The truth is that this future has already begun, and its origins lie not in secret laboratories, but in something much more accessible: 3D printing. Thanks to this technology, it is now possible to create complete robots from a computer, piece by piece, as if they were built by digital magic. In this video, you'll discover how the humanoid robots of the future are born, how their bodies are made, how they come to life, and why they're about to change everything. For a long time, when someone thought of a robot, the most common image was that of a large, rigid machine full of cables, motors, and metal parts, assembled one by one in highly specialized factories. However, that vision changed completely with the arrival of a technology that transformed the way we create objects: 3D printing. Although not a recent invention, its progress in recent decades has been so rapid that today it allows manufacturing everything from small parts to complete structures, layer by layer, using materials such as plastics, metals, resins, or special high-strength composites. It all begins on a computer, within a 3D modeling program where the designer or engineer digitally shapes their idea. That model, which previously could only be stored on a screen, is converted into a file that the printer interprets as a series of exact instructions for depositing material, millimeter by millimeter, until the physical object is constructed with almost artisanal precision. The fascinating thing about this process is not only its precision, but the creative freedom it offers. 3D printing eliminates many of the limitations once imposed by traditional manufacturing. Expensive molds and giant production lines are no longer required to develop a single part. Today, all it takes is a printer, a digital design, and the right material to create complex shapes, impossible curves, and internal structures that previously could only exist in computer simulations. But perhaps its greatest impact has been the democratization of technology. What once required large investments and industrial machinery is now within reach of students, inventors, and small laboratories. Universities, research centers, and even enthusiasts can build their own robots, tools, or customized devices from their homes. 3D printing opened the door to a new era in which anyone with an idea and creativity can become a creator, marking the beginning of a true revolution in modern robotics. Why has 3D printing become essential in the creation of modern robots? The answer lies in the advantages it offers compared to traditional methods. Previously, manufacturing a part with internal curves or ventilation channels required specialized tools. Today, it's enough to model it digitally and let the printer do the work. Each robot can be custom designed. From an ultra-delicate surgical arm to a home assistant or an educational robot, everything is tailored to the task it will perform. This opens up a range of possibilities in medicine, education, and industry. Metal molds and multi-million-dollar machinery are no longer required. The essentials are filament spools, electrical power, and good digital design. What once required weeks of work and expensive industrial equipment can now be achieved in just a few hours thanks to 3D printing. This advancement has completely transformed the way robots are developed, allowing functional prototypes to be manufactured in record time and with impressive precision. The speed of production drives innovation and facilitates continuous experimentation. Furthermore, the technology is no longer limited to large companies or specialized laboratories. Now, anyone with a 3D printer can design, print, and assemble their own robot from home, turning robotics into an open, accessible space full of creative possibilities. In short, 3D printing has transformed robotics into a much more accessible, faster, and more efficient field. Today, anyone with an idea and the right tools can design and manufacture complex parts without relying on large factories. This technology has fueled a new era of innovation, where inventors, students, and developers are creating customized robots at a lower cost and with greater creative freedom, accelerating technological advancement worldwide. When 3D printing and robotics combine, the result is simply revolutionary. Imagine you need a robotic arm capable of moving fragile objects with surgical precision. With digital design, you can print the exact parts, modify the size, shape, or strength to suit your needs, and have a working model in just one day. Today, many companies manufacture 3D printed metal structures, which are lighter yet just as strong as traditional ones. Others create custom plastic casings to protect sensors and electrical systems, while researchers develop low-cost prototypes to test ideas before investing large sums. This synergy not only saves materials, but also reduces waste and production costs, maximizing resource utilization. Even space agencies like NASA are using 3D printing to manufacture parts for robotic explorers, reducing their weight by up to 70%. This translates into fuel savings and greater efficiency on missions beyond Earth. The conclusion is clear. Robotics no longer depends exclusively on large factories, but can be developed in laboratories, universities, or even garages equipped with accessible technology. Within the world of 3D printed robots, there are two branches that are changing the landscape: hard robotics and soft robotics. These are traditional robots: metal structures, rigid parts, steel gears, and electric motors. Its main advantage is its strength, durability, and precision. Thanks to 3D printing, its joints, covers, and actuators can now be produced quickly and at a lower cost. This field is more recent and is directly inspired by biology. Instead of hard components, flexible materials such as silicone, rubber, or elastic polymers are used. This allows the creation of robots that imitate human muscles, skin, or tissue, achieving smooth and natural movements. Thanks to this technology, adaptive prostheses, smart medical devices, and robotic suits have been developed to assist people with reduced mobility. 3D printing is vital here because manufacturing flexible materials using conventional methods was extremely complex. Today, with specially formulated silicone resins, soft components can be printed that retain their shape, integrate with electronic systems, and work in conjunction with artificial intelligence algorithms. And the most interesting thing is that the two branches don't compete. They complement each other. The robots of the future combine a solid, sturdy structure with flexible elements, more faithfully imitating the movements of a living being. Creating a humanoid robot with 3D printing may seem like science fiction, but it's actually a process full of precision, creativity, and method. It all starts with an idea. It could be designing an intelligent prosthesis, an educational assistant, or a mechanical arm that assists with specific tasks. First, the robot's purpose, its function, and how it will interact with its environment are defined. Then, the idea becomes a sketch, which is passed on to 3D modeling software where every part, from joints and internal structures to spaces for motors and sensors, is designed with millimeter accuracy. This digital model is transformed into a file called G-code, which translates the design into detailed instructions for the printer, telling it how to move the head, what temperature to use, and how to place each layer of material. Before printing, technicians prepare the machine by adjusting the temperature, speed, and type of material, whether plastic, resin, or metal, depending on the required strength. Once everything is set up, the show begins. The printer deposits the material layer by layer, shaping the robot while specialists monitor for errors or deformations. Some small parts may take only a few hours, but more complex ones can require days of continuous work. When printing is complete, the parts are cleaned, scraps removed, and polished for a perfect finish. Then comes the assembly stage, where motors, cables, sensors, cameras, and control systems are integrated. Each element must fit together precisely to ensure fluid movements and secure electrical connections. Once assembled, the robot is turned on for the first time. Engineers load the control software, calibrate the motors, and test the joints, fine-tuning every parameter until a natural response is achieved. At that moment, the creation comes to life. A digital design has become a functional machine, capable of moving and reacting to its environment. What was once only achievable in multi-million-dollar factories can now be done in a small workshop or even at home. 3D printing has transformed robotics into an accessible, flexible, and fascinating process where ideas cease to be mere concepts and become, layer by layer, authentic creations of the future. Although the 3D printer is the protagonist of this story, there are other lesser-known but equally important tools for a perfect process. One of them is blue painter's tape. It may seem simple, but it prevents parts from slipping during printing, ensuring the layers stay firm. There is also isopropyl alcohol, which cleans the print bed and ensures the first layer adheres properly. And precision pliers are a must, ideal for removing filament remnants and detaching parts without damaging them. In robotics, every detail counts. A small error in adhesion or a surface imperfection can cause the robot to not move as it should. Therefore, mastering these tools is key. They are not mere accessories, they are the invisible allies that determine whether a prototype will be a success or a failure. To close this tour, let's look at an example that perfectly represents what 3D printing has achieved. InMove. It was created in 2011 by French sculptor Gaël Langevin. His idea wasn't to build a commercial product, but rather to explore the limits of combined art and technology. The result was a 1.80-meter-tall humanoid robot composed almost entirely of 3D printed parts. The amazing thing is that InMove is an open project. Anyone can download the plans, print the parts, and build their own robot at home. Its design integrates cameras, pressure sensors, and visual recognition, allowing it to perceive its surroundings and react in real time. Today, InMove is used as an educational tool in universities and laboratories around the world, teaching programming, mechanics, and electronics. He is living proof that the future of robotics belongs not only to large corporations, but also to those who dare to experiment. The union of 3D printing and robotics is redefining what we understand by technology. What once seemed exclusive to movies or secret laboratories can now be created in any workshop or even a bedroom. Every advancement brings us closer to a future where robots will not only work alongside us, but will also learn, sense, and evolve with us. The factory of the future is no longer in one place. It's in every 3D printer, in every creative mind, and in every idea that becomes reality.